The whole point of differentiation is to find the gradient of a graph. Gradient is rate of change. So in differentiation, we work out dy by dx, right? This is the rate of change of y with respect to x, essentially, to put it in a really complicated way. But differentiation is just working out gradient. Okay, that's the theory behind it. Let's have a look at a question and how it's applied. So it says, this one. It says, let fx equal 4x squared minus 8x plus 3. Find the gradient of y equals fx at the point a half 0. Okay. You want to first work out f dash x. You want to differentiate. Now, when you have a quadratic or when you have any equation and you're trying to differentiate it, just differentiate each term separately. So try that. Give it a shot. Try and differentiate 4x squared minus 8x plus 3. You're going to do each one separately. So to differentiate this, you're going to times by the power 8, you're going to write the letter x, you're going to minus 1 from the power 1. So you're just left with 8x. Okay, this one, you times by the power minus 8, you write the letter x, and then you minus 1 from the power. 1 minus 1 is 0. Anything to the power of 0 equals 1. So we're left with just minus 8. And then the 3, you can't differentiate. There's no letter. So it just becomes 0. So when you differentiate, you get 8x minus 8. Cool. You want the gradient at a specific point. So what you're going to do is you are going to sub in the x coordinate half. 8 times a half minus 8. So 4 minus 8, which is minus 4. So at the point a half 0, your gradient is minus 4. Part B. Find the coordinates of the point on the graph of y equals fx where the gradient is 8. So where the gradient is 8. We worked out the equation for the gradient. 8x minus 8 equals 8. 8x equals 16. X is going to equal 2. That is your x coordinate. You're going to plug that into your original equation. 4 times 2 squared minus 8 times 2 plus 3. To work out the y coordinate, which is going to be 3. Y equals 3. So your coordinate is 2, 3. That is when the gradient of the line or curve or whatever the function is 8. Okay. Part C. Find the gradient of y equals fx at the points where the curve meets the line y equals 4x minus 5. Okay. Curve meets line. Curve is 4x squared minus 8x plus 3. That's going to equal 4x minus 5. Now what you're going to do is solve for x. So can you try that for me, please? So after moving everything around, should have got something like this. Divide everything by 4. You get that? Factorize. And solve. X equals 2, x equals 1. Okay, you want the gradients at those points. So when x equals 1, f dash minus, sorry, no, not minus 1, f dash of 1 is 8 times 1 minus 8, which is 0. So at the x coordinate 1, your gradient is 0. At the x coordinate 2, your gradient is 8. There you go. That's how you do it. Cool. So have a look at this one. Question 5 for me, please. Okay. Find the gradients of the curve y equals x squared minus 5x plus 10 at the points A and B, where the curve meets the line y equals 4. Curve meets line. So curve meets line. Okay, so that means, x squared minus 10x plus 6 equals 0. So x is, why have I written 10? 5, sorry. X minus 3, x minus 2 equals 0. So x equals 3, x equals 2. Okay, we want to work out the gradient of the curve. So we want to work out dy by dx of the curve. You're going to differentiate each thing separately. When you differentiate x squared, you get 2x. When you differentiate minus 5x, you get minus 5. When you try and differentiate 10, you get 0. So that's it, 2x minus 5. Now, when x equals 3, dy by dx equals 6 minus 5, 1. And when x equals 2, dy by dx equals 4 minus 5, minus 1. Okay. So, at 3, 4, the gradient equals 1. And at 2, 4, gradient is minus 1. There you go. That's how you do that.